Good evening, everyone. I like myself a good cup of tea. Cheers to you. This tea is terrible. You know, I'm very picky about my tea. My tea needs to be precisely at 99 degrees Fahrenheit. But this cannot be at 99 degrees Fahrenheit. This is terrible tea. So what's the temperature of this tea? It's 110 degrees. 11 degrees too hot for me to enjoy my tea. You know, I think I have a solution to this predicament. I'll wait a half hour till it cools down. As you can see, it is 6 o'clock right now. I shall wait till 6:30 for my tea to cool down. I will dance in the meantime. I should check the time. What do you know? It's 6:30. I'm going to go check on my tea. This is too cold. What shall I do? As I have found out, waiting 30 minutes was just too long for my tea to cool down. For now it is at 91 degrees Fahrenheit, exactly.
Yeah.
Ready?
Mm-hmm.
All right. I have found Take two. I have found a solution to this problem. Fig Newton's law of Cooolin. D sub 0 is the initial difference of my tea. Meaning, my tea at 110 degrees minus the outside temperature. E is a constant variable. K is the rate at which my tea cools down. T is the time at which my tea cools down. Now D is the current temperature of my tea, the current difference. Meaning, the temperature of my tea now minus the outside temperature. Now let's start with A. A is the current difference in temperature of my tea. Meaning, my tea was 91 degrees Fahrenheit now. And so I must subtract the outside temperature, which according to AccuWeather.com, it is 69 degrees Fahrenheit. So, 91 minus 69 is 22. That is A. Now let's do A sub 0. A sub 0 is the initial difference in temperature of my tea. Meaning, I started out with 110 degrees Fahrenheit tea. So I must subtract that by the outside temperature, which is 69 degrees. Therefore, A sub 0 in this equation is 41 degrees Fahrenheit. Now let's solve for T. T is the amount of time I waited for my tea to cool down. I waited approximately 30 minutes. Now we are left with our final variable, K. K is the rate at which my tea cooled down. Blast! I don't know what K is. I have to find it. So this is our equation. 22 equals 41e to the k30 power. Let's solve for k, the rate at which my t cools down. First, we'll divide by 41 on both sides. Now, we have 22 divided by 41 equals e to the k30 power. Now to get k down to here, I must ln both sides. When I ln both sides, the e poofs away. So now I'm left with ln 22 divided by 41 equals 30k. Now I simply must just divide by 30. Now, I have k equals ln 22 divided by 41 divided by 30. Now let's punch that into our calculators. So let's solve for k. We must punch this into our calculators. Let's do ln 22 divided by 41 close parentheses divided by 30. Enter. And I get negative 0.02075 blah blah blah, a long decimal number. Now if I only keep 3 decimal places, I will get an inaccurate decimal answer. So I must keep all of this. But I don't want to have to memorize all 9 digits of this number, so I can simply store my answer into the calculator. By doing this, I must press STOW right above the ON button on my calculator. Then I will press alpha, and then I will go to K right above the left parentheses button. Enter. So now, every time I use K, it will give me that decimal answer. So now that we know K, I can solve for how long I need to wait for my tea to cool down to 99 degrees Fahrenheit. So, A is going to be my new current difference in temperature, which is 99 degrees. So, I will do 99 minus the outside temperature, which is still 69 degrees. 99 minus 69 is 30. So therefore, my new A is going to be 30. So now we are solving for T. We know what K is, but for the sake of space, I have kept it at K. So now, we must do the same thing. Let us first divide by 41. Now, we must get rid of the E. By doing so, we must ln both sides. Now, all we have to do left is divide by K. Now, let us solve for T. Let's punch in ln 30 divided by 41, close parentheses, divided by alpha K. So, our answer is going to be 15.05348,557, or 15 minutes, 0.053. So, I must wait 15.053 minutes for my tea to cool down to 99 degrees Fahrenheit. Alright now, I have brewed myself a new cup of tea and have waited 15 minutes, 0.053. According to my calculations, this tea should be at 99 degrees Fahrenheit. Let's find out. Marvelous! It is at 99 degrees Fahrenheit.